So welcome to lecture series on data structure. In the previous lecture series, we have discussed about collision resolution technique, linear probing with the help of an example. So this is the case where collision occurs and we applied linear probing technique. Hope you understood how this linear probing is used for resolving the collision. In this lecture, we will discuss about the concept behind double hashing. So as we have seen earlier, double hashing make use of two hash functions. The initial hash function is same as the previous one that we have defined, key value modulo table size. The second hash function will come into play when collision is caused as the result of first hash function. So here an offset index is provided to store the value. The formula for a double hashing is as follows. So the first uh, hash value, which is the value obtained from the function key value modulo table size plus I into second hash value modulo size of the table. Here I is the offset value. Initially this I will be 1 and this offset value will keep incrementing until it finds an empty slot. For example, let us assume we have two hash function h1 and h2. So in order to find the empty slot, these steps has to be followed. So first we have to find if hash one of key is empty. That is, index obtained from the first hash function is empty or not. If yes, we can store the value in the slot. If this hash function is not empty, then we will find another slot using the second hash function. We will check if hash value of the first function and the hash value of the second hash function is together is empty. If yes, the value stored in this slot. If not, you will keep incrementing this offset value, which is called as counter here. So this offset value will be incremented and repeated with hash 1 of key plus 2 into hash 2 of key. Again, if empty slot is now found, you will repeat hash 1 of key plus 3 into hash 2 of key, and it keeps on going as long until you find an empty slot. So here is an example for double hashing. So the first hash function is like key value modulo 20. Second hash function is like key value modulo 13. So the final double hashing function would be like h1 of n plus I into h2 of 2 modulo 20. So here, with the help of the first hash function, we have obtained for the value 16, we have obtained the index of 16. So initially this is an empty slot, so it is stored. And for 8 modulo 20 is again 8, and its slot is empty, we will store 3, 7 until, see, here we will not have any problem. But when it comes to 48, 48 modulo 20 will be 8, but we have already we have a value in the slot 8, so we cannot store. Now you apply the second function, h of n comma 1. So at that time we got an empty slot 9. Again, value is stored in this slot 9. Again, we cannot consider this a slot as empty and we cannot store. And again incrementing this offset value from 1 to 2. So when I'm applying the hash function, I'm getting the slot as 12. So there are no values stored in the slot or the index 12, and this is considered as empty. So I can store the value 48 in the index 12. So if you see this value 69, again, when you apply the first hash function, you got the index as 9, but already we have a value in this index, so it is not empty. So I'm incrementing offset by 1 and I'm applying double hashing. When I apply double hashing, I got index value as 10. Now the slot 10 is empty, so I can store 69 into this slot. So this is how double hashing will work. So it has a high computation cost, but it searches the next free slot faster than the linear probing. So it is most preferred, double hashing. So a hash table is an implementation of associative array, which is used to implement abstract data types. It compares the index into an array of buckets or slot until it finds empty slot. This is used to implement map-like data structures. Hash tables are preferably used for implementing maps. It is very much used in modern computers for implementing things like dictionaries in Python, associative array in PHP, Java hash tables, etc. So these hash tables are usually implemented in languages as an array of value sorted by their keys. It is the application of hashing function includes cryptography, as I said earlier. It is used in cryptography and network security and in document fingerprinting, where you want to find a fixed length output for a given input. In cryptography, hashing is used to ensure that message or document has not been tampered with. If document or message is altered in any way, the hash value is also altered. It is almost impossible to create a document or message with create a document or message with a given hash value. So these are various applications of hashing function. So we have seen the example for double hashing here. Hope you understood what is hashing. With the help of example, I have explained. Uh, so if you have any doubts, let me know. Thanks for watching.